Okay, we have lesson number 2 here in Unit 1. What we're going to be taking a look at is the different characteristics of elements found within the periodic table, and then trying to decipher, based on looking at atomic structure and electron screening, why we notice certain issues with the trends. And this will lead us into lesson 3, which we'll go back and look at some of these trends again when we start to look at specifically what orbitals or what shapes of orbitals do the electrons actually exist in. And this will give us a lot of insight into how molecules are shaped and why they react the way that they do. A lot of really important stuff later on, especially in organic chemistry. So what we're going to do is just quickly break down the 4 characteristics. So the first one we're going to look at right now is atomic radius. Alright, in a nutshell, atomic radius is the distance between the nucleus and the outermost energy level that you'll find electrons in. So to do just a real simple diagram of what that might actually look like, we've got a nucleus here, and we'll set up a whole orbital the electrons might exist in. And so if we're going to actually take a look at what that will look like, the radius would be from the nucleus out to the outer energy level where we'll find some electrons in. I'll just put a couple in here just so that we see that. There we go. So this element right here would be beryllium, right? 4 electrons. And so that would be the atomic radius. Now, one of the interesting aspects of the atomic radius that we're noticing is, as here, we notice that the largest atomic radii are found always in the alkali earths. So they're always in the first row. And then as you go across, you notice that there is a decrease in the atomic radius. So the question is why? Why do we have the radius decrease as we add more electrons? Well, what you need to think about again is the screening to proton ratio. One of the things we have to remember is that screening does not increase as you go across a period. This is really important. And so what does that mean? Well, if the screen does not increase go across a period, then what is increasing? Well, what is increasing is your net positive charge in the nucleus. And so what we're doing is we've got more positive charges as we go across. That, of course, will increase the attraction. So as we go across our periodic table, we're going to see a net increase in the force of attraction.